let's take a look at the graphs of quadratic equations. Remember those? The x squared equations? Well, here's one.
With all due respect, sir, I believe this is going to be our finest hour.
You're used to graphing lines. Let's put in some points and see what happens. If we put in 0, we'll get 0 squared, or 0. Let's graph that point. That's easy. Now let's put in the next easiest point, or number 1. 1 squared, remember, is 1 times 1, or 1. So we'll go over 1 and up 1. Starting to look like a line, isn't it? Now I'm going to throw something crazy at you. I'm going to put in negative 1. Negative 1 squared, which is negative 1 times negative 1, equals positive 1, doesn't it? And if you look at the point negative 1, positive 1, it doesn't line up, but we didn't make a mistake.
Wait just a minute.
Let's put a couple more numbers in. We'll put in 2, just to see what's going on here. 2 squared is 4, and the point 2, 4 is right there. And I'm going to put in negative 2, because that'll be easy also. Negative 2 squared is also 4, isn't it? If I go back 2 and up 2, what do you have here? A curve. Whenever you have a function that has an x squared in it, it forms a curve. Let's make sure that wasn't just a coincidence or a freak of nature.
Holy alphabet.
How about this one, where we have more than one x, but we do have that x squared? I'll start off with 0. Of course, I'll put a 0 everywhere that I see x. And 0 squared plus 2 times 0 minus 1 is minus 1. So the point 0 minus 1 will go right there. Now let's see. I'm going to put in 1 again. But remember, I put it in every place I see x. And I get a 2. 1 plus 2 is 3, minus 1 is 2. So the point over 1 and up 2. And just like last time, I'm going to put in minus 1, just to make things go quicker. Putting in a minus 1. Remember, minus 1 squared is positive 1, and 2 times minus 1 is negative 2. 1 plus a negative 2 and a negative 1 equals a negative 2. Now, negative 1, back 1 and down 2. What's going on here? They're not lining up, they're kind of curving. Let's put in negative 2. Negative 2 squared is positive 4, and a negative 4, and a negative 1. It's coming back up. In that case, y is negative 1. So I go back 2 and down 1. Let me put in one more number. Put in negative 3. See if it comes back up. Negative 3 squared is positive 9, and 2 times negative 3 is negative 6, and all that equals a positive 2. So let's go back 3 and up 2, and son of a gun, I still have a curve. It's just in a different place. Well, I wonder if it's always going to look like that. Let's try something like, let's try a negative x squared term, negative 2x squared. I'll put in a 0. Of course, I'll get a 0. I'll graph that point. If I put in a 1, I'll get, got to do the 1 squared first, order of operations and all, and then negative 2, and I'll get negative 2. Over 1 and down 2. Now I can't resist. Let me try that negative 1 again and see what happens. Negative 1 squared is positive 1, times negative 2, I get a negative 2, don't I? Now back 1 and down 2.
Oh, it didn't work.
Oh, it did.
Surprise, surprise, surprise.
It's still a curve, it just opens downward.
Are you pondering what I'm pondering?
Well, what I need you to know, anything that contains an x squared,
I know you are, but what am I?
it's going to be, we'll call it quadratic, is either going to look like a curve opening upward, that's if the x squared term is positive, or a curve opening downward if the x squared term is negative.
There's something I have to ask you.
Now, since you know you're going to have to come up with these curves, typically a student asks,
I'm trying to think, but nothing happens.
they ask, how did I know what numbers to put in? And I know a secret.
Houston, we have a problem.
I mean, consider, what if I had put these 4 numbers in? How would I know where the curve was? Could be there, could be there, could be there,
Ay, caramba.
could even be there, couldn't it? Because it could open downward. So how do I know which numbers to put in?
Perhaps I could be of some assistance.
Well, this point, the middle point if you would, is called the vertex. No matter what curve you have, the middle point, the maximum or the minimum point, is called the vertex.
Here's someone who can help you.
And I can find that vertex if I consider that every quadratic equation, x squared function, is going to be of the form ax squared plus bx plus c. A number in front of x squared is the a, the number in front of x is the b, and the constant, the number sitting by itself, is the c. Do you know that the vertex will always be at negative b over 2a? In this case, the vertex will be at negative of 2 over 2 times 1. Or, let's see, negative 2 over 2 times 1, it'll always be at negative 1. Now that's the x. How do you know what the y will be? Well, put negative 1 into the formula, and it tells you what the y is.
Oh, dear. That's too wonderful to be true.
It is, because once you know where the vertex is, it's going to be very easy to pick the correct numbers to put in to graph that quadratic equation.
Oh, is this great?
Let's try this one. In this case, the vertex is going to be at, of course, negative b over 2a. Now a is 3, b is negative 6, and c is 1. So the vertex will be at negative of negative 6 over 2 times positive 3. Now remember, the negative of a negative is a positive, so we've got 6 over 6. It's going to be at 1. So the number I'm going to put in
Now what am I going to do?
is going to be 1.
You have chosen wisely.
Watch. I put in a 1, and I'm going to get a negative 2. The point 1, negative 2 is not only on this graph, but I know it's the vertex.
Hey, man, check it out.
Okay? Now, I'm going to graph 1 point to the right, or put 1 point to the right of that number, which in this case will be 2. Putting in a 2, I'll get a 1, the point 2, 1. And I'm going to put, I put 1 point to the right. Now I'm going to put 1 point to the left. That's 0. I love 0. Putting in 0, I get a 1. The point 0, 1. Oh, this is looking good. I know it's a curve, and I already know where it is.
Woohoo! Time to pop up.
I just draw it. So once you find that vertex, do 1 point to the right and 1 point to the left, and you're there.
Now I use my secret weapon.
You can check my answer with your calculator. Here's the buttons you'll use. The y equals button. That's the X button. That's the graph button. And the clear button. Of course, the on button. If you turn your calculator on, hit Y equals, you might have to clear out something from previous class. So hit the clear button. And then type the equation we just did, x to the second, or x squared plus 3x minus 2. And then hit graph, and son of a gun, you'll see the picture. Now if you want to get rid of it, hit clear. Want to do another? Remember that when you want to do a second one, you're going to have to hit clear to clear out the first one. And remember, there's a difference between the subtraction and the negative. Let's try an upside down one. If your calculator's not on, turn it on. Hit Y equals. Now clear out what you already had with the clear button. And this time put negative 2x squared plus 3. Okay, now that's the negative button. Negative 2x squared plus 3. And if you hit graph, I hope you're not surprised that the graph opens down, doesn't it? Okay, go ahead and clear out. I can't help bringing up one of the major reasons why we cover parabolas and their vertexes and the quadratic formula and such. And that is, do you know that any free-flying object, because of the force of gravity, follows a parabolic path? Any free-flying object. Even a bullet follows a parabola. It may look like a straight line, but any sharpshooter would tell you that it's a very low-lying parabola. Any free-flying object. So we can use a quadratic function to predict where something's going to be, maybe even where it's going to land, which is pretty important for many free-flying objects. Other quadratic realities are that business applications can be predicted many times using a quadratic path. Even social applications occur in a quadratic fashion. Now, why do you care about that? Here's where I think it gets very interesting. If sales follow a quadratic path based on price, for instance, and we want to maximize our sales, well, we want to find the highest point for our sales, then what are we looking for actually is the vertex of this graph or this function. If we want to minimize, for instance in this case, our tax, again, the minimum or lowest value would be the vertex. Okay, and we now, of course, know how to calculate these type of things. Now, it's one of the confusing things for students is typically when do you use the vertex formula and when do you use the quadratic formula? Well, let me give you some clue words that'll help you. I hope you appreciate that whenever you're going to be looking for a maximum or the word minimum, biggest, smallest, highest, lowest, anything like that, you're going to be looking for the vertex, and you're going to use the vertex formula. As opposed to the quadratic formula, if you're not looking for a maximum or minimum, and one of the key words is they say to solve something. When you're solving an equation, of course, that's going to use the quadratic formula. And remember, the quadratic formula has two answers. So just about any time you're looking for two answers, you should smell the quadratic formula. Graphically, if we look at a parabola, I hope you appreciate the quadratic formula finds the spots where y is 0. The two x values where y is 0. Whereas the vertex formula finds the x value only, where y is at its highest point. So that black point, remember, is a point, and any point has two coordinates. Two coordinates. The vertex formula, negative b over 2a, only gives you the x value. You get the y value by placing that x value into the function and actually finding the height of y at that x point. Let's try a couple examples.
Pay attention, boys. I'll show you how it's done.
Say the height of a little leaguer's football punt can be approximated based on the time it's in the air, time in seconds, by the function h of t equals negative 12t squared plus 36t plus 3, where h of t is the height and t is time in seconds after it has been kicked. It's going to look like this, of course. You smell a parabola. Now, let's look at that parabola and suppose Mom is standing on a platform that is 20 feet above the ground and wants to take a photo of Junior's kick. Our question here is, at what time in seconds will the punt be at exactly that 20-foot height? Well, I hope you appreciate it's actually going to be at 20 feet high twice. Two different places. So I smell the quadratic formula. Now remember the function. That was the original function, as you see. Now I hope you appreciate, in this situation, we want to know when that function calculates to 20 feet. So I'll plug 20 in for h of t. The problem is, and it's not a big problem, the quadratic formula only finds zeros, so we have to get a 0 where that 20 is. Well, that's not too bad. We'll just subtract 20 from both sides, and now we have the function in a form that we can use. In this case, a, I hope you appreciate, will be negative 12, the number in front of t squared. B will be 36, the number in front of t. And c will be the negative 17. Now we'll plug those values into the quadratic formula and simplify. I'll do that for you this time. You'll do it in the homework. Taking the square root of 480, of course we get two answers, plus and minus. So we're going to get two answers to this solution. Now, if you use your calculator to find out what that square root is, and then actually add and subtract it and get the two answers, you'll get 0.6 seconds for this location and 2.4 seconds for that location. So these are the times when the ball will be exactly 20 feet high. Definitely an appropriate use of the quadratic formula.
There's something I have to ask you.
Now, if you know anything about kicks, you're going to want to know the hang time of this kick. That means, in other words, how long, when will it hit the ground? How long will it be in the air? Well, we can use the same function, but this time we're not going to put in 20. Of course, we're putting in the height of the ground. What is the height of the ground? Well, it's 0.
I know that, dude.
So this is maybe a little easier problem. We're still solving. We're solving this equation. So I smell the quadratic formula. But in this case, A will be negative 12, B will be 36, and C will be 3. If we plug that in and then simplify and then take the square root. Now if we add and subtract that square root, we'll still get two answers. Now this is a little bit different than the last one because we only wanted one answer, but we will still get two answers. One of them will be negative 0.1 seconds, and the other one will be 3.1 seconds. Now we can't, unless we have a time machine, we can't go back in time. So get rid of that answer, and our hang time will be 3.1 seconds. And I'm afraid that Junior is not going to go to the NFL with a hang time of 3.1 seconds, but that's when it hits the ground after he kicks it. Now, one last question. When does the ball reach its highest point? And that's when it hits it. And how high is it at that highest point? we can even find these things out. I hope you appreciate using the same function. When you see the word highest, we're talking about this area right here. And it even looks like it. We have a fancy name for that, you may remember. That's the vertex. So we're going to use, in this case, the vertex formula to find at what point that will occur. So in this case, again, A is negative 12, B is 36, and C is 3. So plugging in those values, negative B over 2A, and simplifying, we get 1.5 seconds. That seems about right. It's about half the time that it took until it hit the ground. Now, just remember, that is the time it took to get to the highest spot. If we want to know how high that highest spot is, we call that the vertex is a point. And a point has 2 coordinates. Now, if we want to know the second coordinate, then, and in this case we do, we want to know h of t at that spot, the height, we have to plug that value, in this case 1.5, into the formula for t and see what it comes out to be. In this case, I'll do that for you, and adding all those numbers up, it comes out to 30, and in this case 30 feet. So it kind of makes sense. So at 1.5 seconds, it's at its highest spot, 30 feet. So you get the idea how we can use the quadratic formula to solve things, and how to use the vertex formula to find what we call maximums, minimums, highest, and lowest. So now,
Transfer of data is complete.
it's your turn. Go try the homework.